Hello, my name is Bara Shoshara. Today I need to present about Pascal's law that we have studied on January semester in engineering mechanics course. So let's start. I have three group members. My name is Bara Shoshara. I'm in the middle, number 2. So can you give me next slide, please? What's Pascal's law? Pascal's law says that pressure applied to an enclosed fluid will be transmitted without a change in magnitude to every point of the fluid and to the walls of the container. The pressure at any point in the fluid is equal in all directions. So, what's Pascal's law and prove it? Pascal's law states that if some pressure is applied at any point of incompressible liquid, then the same pressure is transmitted to all of the points in liquid and on the walls of the container. Let us imagine an arbitrary right-angled prismatic triangle in the liquid of density P. Next slide. So what's Pascal's law and an example of Pascal's law? One of the most common examples of Pascal's law is the hydraulic braking system present in the automobiles. Every time you see a car come to a halt, the principle of Pascal's law comes into action. A number of components from the braking system in cars. So that's my slides, and that's what I present. I'll give my team member Muhammad Daniel Fitri.
All right, so what is the formula for Pascal's law? So as you can see here, we have an enclosed system of liquids, incompressible liquids. So we let the smaller piston be piston A, and the bigger piston will be piston B. We know the pressure on piston A is bigger than the piston B. So S pressure equals to force over area, cross-sectional area, to be precise. Hence, according to Pascal's law, force 1 over cross-sectional area 1 is equal to force number 2 over cross-sectional area number 2. All right. So next slide, please. All right. So from the Pascal's law, from the perspective of from Newton's law and forces, we use this as you can see in the image. This is an example of hydraulics where force get amplified. As you can see, we only use a small piston with a small force on the smaller side of the piston. And thanks to the Pascal's law, we are able to lift this truck with significantly large force using a significantly bigger cross-sectional area of a piston. All right. So how does Pascal's law work in a hydraulic jack? So the hydraulic jack is a device used for lifting heavy loads by the application of much smaller force. It is based on Pascal's law, which stated that intensity of pressure is transmitted equally in all directions through a mass of fluid at rest. All right, so what are the three applications of the Pascal's law? So we have three tools that make use of the Pascal principle: the hydraulic brakes, the hydraulic lifts, and the hydraulic presses. Now I pass the mic to Iqbal Hamidi to continue the presentation.
Thank you. Now I will present about hydraulic brakes. The firstly is hydraulic brakes. Hydraulic brakes work on the principle of Pascal law. According to this law, whenever some pressure is applied on the fluid in the traverse, uniformly in all directions. Therefore, we apply for force on a small piston. The pressure will get created, which is transmitted through the fluid to a larger distance. The second is that hydraulic lift. The principle of hydraulic lift is based on the Pascal law for generating force or motion, which states that the pressure change on a incompressible liquid in a confined space in a passage equally throughout the liquid in all directions. The firstly is pressure is exerted on a fluid in a small cylinder, usually by the compressor. The secondly is that pressure is exerted equally in all parts of an enclosed static fluid, Pascal law. The next is the force in the small cylinder must be exerted over a much larger distance. A small force exerted over a large distance in the track. Lastly is that the pressure in the same. It is exerted over a much larger area, giving a multiplication of force that leave the car. The lastly is the hydraulic pressure. The hydraulic press works on the principle of Pascal law, which states that when pressure is applied to a confined fluid, the pressure change occurs throughout the entire fluid. So I will give a sample for Pascal at the daily life. For example, like toothpaste. Fast for according to Pascal principle, a change in the pressure at any point in the enclosed fluid will be transmitted equally to all parts of the fluid. So thank you. Thank you. I hope you all can know about Pascal, know knowledge about Pascal. So thank you.